With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there are three particles, each of mass m, which can slide on a fixed frictionless horizontal circular track in the same horizontal plane as shown in the figure. Now the coefficient of restitution is given as to be 0.5, and m2 and m3 are at rest initially and lie along a radial line before impact. And the string is initially unstretched. We need to find what is the maximum extension in the spring in the subsequent motion. So let's say this is our mass 1, this is our mass 2, and this is our mass 3. This is our mass 3. Now initially only our first mass is moving, so it would have an impact with the m2. So m2 would be moving. Now m2 is connected with m3 through the spring. So if m2 moves, so m3 would also move, and then there would be an extension in the in the spring. We need to find what is the maximum extension value. So how can we do it? So first of all, we should find just when m1 strike m2, what is the velocity which m2 got. So first of all, we should determine this value. How can we do this? So when they would be impacting, let's say this is our mass small m, and this is another mass, let's say small m, because the masses are equal. Now it is coming with the velocity v naught. Okay, so whether the collision is elastic or inelastic, momentum would be conserved. So we can say that initial momentum is m into v naught. This would be equals to, let's say after the collision, this mass, or we say that this is our first mass, this is our second mass. So the first mass moved with a velocity v1, and let's assume that second mass moved with a velocity v2. This is the second mass. So initial momentum is mv0, final momentum would be m v1 plus m v2. So we can say that v1 plus v2, this would be equals to v0. Let's say this is our equation 1. Now we have been given with the value of coefficient of restitution. So we can say that coefficient of restitution is defined as the ratio of velocity of separation to the velocity of approach. So what is the velocity of separation? It would be v2 minus v1. v2 minus v1. And what is the velocity of approach? Since it is at rest, so velocity of approach would be just equals to v0. Okay. And this value has been given as to us as 0.5. So from this expression, we can say that our v2 minus v1, this would be equals to 0.5 v0. Let's say this is our equation 2. Now if we solve this equation 1 and 2, then we can get the value of the v1 and v2, and these v1 and v2 would be just after first strike the second. So it is just after the first strike the second. So solving this, our v1 would turn out to be v0 by 4, and our v2 would turn out to be 3 v0 by 4. Now these are the values, okay, just after the collision. Now what will happen? So it would try to move. So it would be moving, okay. So it would be moving with a velocity which has been given by this 3 v0 by 4. Now due to this, when it would move, so similarly it is connected to the spring, so this would also move. So for the case of maximum extension, the angular velocity of our mass 3, let's say this is omega, and angular velocity, so we can say that it is omega 3, and angular velocity for the case of maximum extension, let's say for our mass 2 around this circular path is equals to omega 2. So for the case of maximum extension, this angular velocity would be same. So we say that for x max, omega 2 would be equals to omega 3, and we call this value as to be omega. Now how can we do this? So first of all, what we can do, so initially only m2 would be moving and m3 would be at rest. Just after the impact, m2 would move and m3 would be at rest. So what we can do, we can just conserve the angular momentum about the center, okay, because angular momentum would be conserved about the center for this system. There is no external torque when it is started to move. There is nothing external torque which is acting. So the initial angular momentum, so Li would be equals to Lf, final angular momentum for m2 and m3. We are just talking for m2 and m3. Now what would be the angular momentum? Angular momentum could be written as m into v into r. So for our mass 2, mass is m, and the velocity is 3 v0 by 4. This is the velocity, and the distance from the axis is 2r, because it is moving in a circle of radius 2r. This would be equals to final angular momentum. Now when it get this angular velocity omega, so what would be the velocity of this? We know that v equals to r into omega. So for our this mass 2, v2 would be equals to, radius value would be 2r multiplied by omega, and for our mass 3, v3 would be equals to r into omega. This would be the value of v3. So we can say that this is the initial angular momentum. So final angular momentum, mass into angular momentum of our second mass, it would be this angular velocity v2, we have written 2r into omega, and the distance would be equals to 2r plus the mass of m3 is m multiplied by the velocity, which is equals to r omega, and the distance is r because it is moving in a circle of radius r. So if we solve this, we can get the value of the angular frequency or angular velocity. It would be 3 divided by 10 v naught divided by r. Now how to get the value of the maximum extension? Now it is very simple. Now the energy which it was having initially after the collision with a velocity v2, the initial kinetic energy would be equals to what? Initially it would be having the this kinetic energy. So if we use conservation of energy, so we can say that initial energy for our system 2-3 would be equals to the final kinetic energy for our system 2-3. Now initially it would be just having the kinetic energy. Now finally, since they would be having angular velocity, so they would be having this kinetic energy, but in spite of kinetic energy, they would, in addition, they would be having the spring potential energy, which would be equals to half kx square. So we just write what is the kinetic energy in the initial case. It is equals to 1 divided by 2 mass of 2, which is equals to m into this square of the velocity. So initially it was having a velocity of 3 v naught divided by 4. This is the initial kinetic energy. Only second would be having. Okay. So for 2 and 3 system, we are just calculating. Now final. So kinetic energy of our mass, our second system m, and the velocity is equals to r omega. So r, which would be equals to 2r for our mass. For this mass, the radius is 2r. So velocity would be 2r into omega, which is 3 divided by 10 v naught divided by r square. So this would be the velocity of our 2. So 1 divided by 2 into mass, and the velocity of 3, this would be equals to r into omega. Omega value would be 3 divided by 10. We just write 3 divided by 10 v naught divided by r, and then we need to have the square. So this is the square plus half k x square. Now if we solve this expression, then our x square would turn out to be, our x square value would turn out to be 9 divided by 80 m v naught square divided by k, or we can say that our x would be square root of all these things. 9 divided by 4, sorry, square root of 9 would be 3. So it would be 3 by 4, 3 divided by 4, and then v naught m divided by 5k in the square root, because 80 could be written as 60 multiplied by 5. So this would be the final. So which option is the correct option? So 3 by 4 v naught m divided by 5k, B is the correct option. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.